Welcome, Regni and Erez and Alexi and Susanna and Stefani, Alexis, Fanu and Adam. Let's go right to the quiz and talk about how to do all those problems. Okay, so the first question on the quiz is use the dot product definition of angle to find the angle between the vectors 2, 0, -3 and 1, 1, 2. You must show your work and leave your answer in exact form rather than a decimal. Okay, so there's one of those, you got to remember the definition. What's the dot product definition of angle? Can you remember?
Is it the vector A, or like, I don't know exactly how to explain. It's a bracket with the arrow on top, A times B cosine theta.
Okay, first it's not times, so I want to fix you on that. It's
okay.
If you have two vectors, I'm going to call them V and W, more commonly used for vectors.
Oh, I thought it was U and V.
Yeah,
you could use when I did homework, I used U.
Yeah, I know the book uses U. I don't think that's good notation actually, because U stands for the word unit. So I tend to use V and W, but U is fine too. I tend to use, if I can, U for unit vector and V and W for non-unit vectors if there's only two vectors. It's easier to deal with, if you have to deal with unit vectors, but we don't on this one, so it's fine. So, right, so we know that the cosine of theta is U dot V over the magnitude of V times the magnitude of W. Okay, so let's go and find the dot product. So let's start out with 2, 0, -3. And then dotted with 1, 1, 2. Okay, you should be able to do this in your head. This is really easy. What do you get? Yeah, you get -4 because it's 2 plus 0 plus -6, which is -4. Any questions so far? Okay, then we need the magnitude of 2, 0, -3. That one, I probably want to use prettier notation on this one just because it's just nicer, I think, but you can go either way. 2, 0, -3. So the magnitude, well, let me try again, see if it does a delimiter.
Larry, I used in relationships, there's the double line.
There it is, got it. So 2, 0, -3. Again, and I never test you on how pretty your quiz looks. What matters is do you get it right? Okay, and you're showing work. And that's going to be equal to the square root. I think that's under basic, is it? Yep, square root of 2 squared plus 0 squared plus -3 squared. And that's equal to the square root of 13. Any questions on that magnitude? Okay, and then we do.
I have a small question. If we were to say, if we just left it as 3 squared and not -3, would you ever take off for that? Even though, because it's squared, it becomes a positive.
I probably wouldn't take off, but technically it's not as pretty. I
Right.
realized I made a little error here in a typo. That should be squared, not cubed. Yeah, that would be if I was in a really bad mood, I'd take off, but probably
okay.
not.
I figured it didn't matter since, like, in my head it organizes better to just be positive, but
right. What does matter is if you have the negative outside the parenthesis, that matters because you get a different answer.
Well, that's why I feel like leaving it positive just kind of keeps me straight.
Yeah, I wouldn't take off points. Technically it should be the -3, but that would be a lot of, that'd be just me being mean to take off points. So it's not a big enough deal. Yeah.
All right.
But I might put a comment. That's what I could do without taking off points. I put comments on your work. So that I could do a comment, but other than that, I wouldn't do anything on there. Okay, so now I want the same thing for 1, 1, 2. So I'm gonna copy and paste so I have all the notation set. So same thing with 1, 1, 2. And that's gonna be 1 squared plus 1 squared plus 2 squared. And that is a square root of 6. Any questions on that? Okay, now we're ready to put everything together. So again, we have the dot product with -4. And root 6 times root 13 is root 78, just multiplying them. So we're going to take the arc cosine of that, and that'll be the answer. So let's do that. Again, it's a lot easier to write this. This is root 78 and -4. So we can say theta is equal to the arc cosine of -4 over the square root of 78. And that's the exact answer. I said, don't write it as a decimal, write it as an exact answer. And this is the exact answer. Any questions on question 1?
If I didn't show my work for the like square root part because that was going to take a long time to type in, but I still like put in the answer square root 13 and square root 6 separately.
Let me show you if you don't want to take a long time, then you just go like this. 2, 0, -3. It won't take a long time, I promise. Is equal to square root of 2 squared plus 0 squared plus -3 squared equals square root of 13. So if you want to go fast, that took me what, 15 seconds? So that's how you make it fast if you want to go fast. Since I'm teaching, making it pretty is a little more important, but not for you guys. Does that make sense?
Yeah, it does. Thanks.
Yeah. So, and I'm giving you this. Remember, the whole point of these quizzes is to practice. Quizzes aren't worth very much, so don't stress about points. But what you should worry about is how you can make this work on an exam, because I could very easily give you this as an exam question. Okay, so if you want to go fast, that's how you do it on an exam, because again, you can run out of time on an exam if you're kind of making it too pretty. Okay, let's look at number 2, and that is find a vector orthogonal to both vectors 3, 2, 1 and 1, 0, -1. You must show your work. All right, so on this one, if you want to find a vector orthogonal to 2 other vectors, what do we do? It's actually quite easy.
Take the cross product.
Yep, take the cross product. So this is just a fancy way of saying what is the cross product of 3, 2, 1 and 1, 0, -1. So I'm just going to write ijk and then 3, 2, 1. And then 1, 0, -1. And that, and let me do this actually, just so I can show you what I'm doing. I'm doing 3, 2, 1, cross 1, 0, -1. And that's equal to this matrix determinant. So now we take the I component, and for the I component, you get rid of the first row and you get rid of the first column, and we find the determinant for 2, 1, 0, -1, which is just -2. So we get negative 2i. And then minus, we take the j component, and that we get rid of the first row and second column. And you get 3 times negative 1 minus 1 times 1, which is negative 4. And it's minus negative 4. So that becomes plus 4. J. And then for the k component, that's going to be a plus. And now we get rid of the first row and third column. And you get 3 times 0 minus 2 times 1. And that's negative 2, so minus 2j. That's it. Any questions on this question? Okay, so now let's go to the last question. And that is, find the work done against the force F equals 3i minus 2j. Yeah, you could write it. So can you write it with bracket notation? You can, but because, you know, when you're doing a cross product, you write this as a determinant. I think it's more natural to write I, J, and K. Oh, except it should be a K in that. There we go. Should be, it's more natural to write it as I, J, and K instead of as brackets for this particular example. Okay. I wouldn't take off points for, you know, writing bracket when you could have written IJK or vice versa, as long as you understand both, and you should understand both. So hopefully that answers your question. Okay, so now find the work done against the force F equals 3i minus 2j to move a particle from the point 4, negative 1 to 1, 5. So who remembers the definition of work? Sorry, force. Force. Work, not force, work.
Force times displacement.
Except not times, but.
Well, I don't exactly know how to explain it, but.
It's a 3-letter word, that's a hint. Dot. Dot. Times is a dangerous word because is times a cross product then? Do you see? So try and get used to dot and cross. There is no such thing as times with vectors. So what we want to do is we want to take the F dotted with, let's call it a, how about PQ for the displacement vector? And that is equal to F, which is 3 comma negative 2. Dotted with, and then we take the displacement, P to Q. So that's going to be, I'll show the work. And that's going to be 1 minus 4, comma, 5 minus negative 1. And that is equal to 3 comma negative 2. And then dot, 1 minus 4 is negative 3. And 5 minus negative 1 is 6. And maybe I should write this too. Let's call it work. Okay, what's 3 comma negative 2 dotted with negative 3 comma 6? Yeah, so it's 3 times 3, or 3 times negative 3 is negative 9. And then plus negative 2 times 6. So it's negative 9 plus negative 12, which is negative 21. Any questions at all on finding the work?
Yeah, I was a little confused just by the wording in the problem because it says the work done against the force. So I did do the dot product of just the force by the displacement vector.
Mm-hmm.
But then I also was like, well, I don't know. So I'm going to also do the negative force by the displacement vector.
I literally copied it from the book. And can work be negative? Yes. If work is negative, that means that it's actually hard to do it. You're not being helped by the force field. Does that make sense? So imagine taking a bike ride along Emerald Bay, which I might be doing today, and there is wind coming against you, then you have negative work. Whereas if the wind is with you, then you have positive work. Does that make sense?
Yeah.
Yeah. So that's kind of where it's coming from. And again, I literally copied this out of the book, the words.
So, just heads up, I did both.
Okay. Well, I'll look at it. I'll look at it. Okay. Switching the order of the points is never okay. Oh, sorry. Switching the order of the points. Yeah. You shouldn't really switch the order of the points. You should always do the second minus the first. Yeah. Don't just say, I need to get positive, so I'm going to switch. You can have a negative work. You can have positive work. It all depends on whether you're being helped or hurt by the force. Right? The wind for you, with you, and the wind against you is very different if you're ever taking a bike ride, right? You can't just switch it. I'd love to be able to do that all the time, but you can't do that. Does that make sense? So positive, negative is very important in this. Okay, and that is the quiz. So I always like it if I can make it in less than 20 minutes. That means you guys can too, even with all your questions and explanations and stuff like that. So I don't feel guilty that this was too long a quiz or anything. So let's go back to the webinar, the agenda. And we are at Q&A time. So are there any questions about homework or I don't know, anything else? Any questions? This is a good time to ask. And of course, I'll have office hours after class as always, so I can answer them then too, but I can answer them now if you have questions. Any questions? I'm getting a lot of silence, but okay, well, if there's no questions, then I'll get to the new material. So what we're doing now is, or in this section, is we're going to look at geometry. So we're going to look at the simplest today. We're going to look at the simplest kind of geometry. When you're in 2 dimensions, what are the simplest geometry pieces in 2 dimensions?
Triangle.
What's that?
Triangle.
They're simpler than a triangle. Yeah, a line and also a point. Hopefully you think points are simple too. Just a point. Triangles are a lot more complicated than a line, okay, or a line segment, because triangles have 3 line segments and it has angles and all kinds of stuff. So definitely a line is simpler and a point simpler. So the reason why really it makes it simple is the derivative is constant, right? You have a constant slope. It's flat. Hopefully you realize that. Whereas as soon as you leave your flatness, then it gets messier, whether it's a parabola or a circle or some kind of sine curve, it gets much messier. So the good news is today, we're only going to deal with the clean stuff in 3D. And we're going to do lines because those are simple. And hopefully you all know lines are straight. So you don't have to worry about calculus because you just have a slope and don't have to worry about it. So who remembers, and let me just put it this way, you better all remember the standard equation for a line in 2 dimensions. Just a good old fashioned one that you learned in 8th grade or something. Yeah, y equals mx plus b. And I did this already when we talked about parametric equations in 2D, where you can think of m as a vector, you can think of b as a vector, and you can think of x instead of x, you call it t, and you get parametric equations. We did that for 2D, but the good news is it works in any D. So here is the equation of the line. Y equals mx plus b. I can rewrite that as y vector equals m vector times t plus b vector. How many dimensions does this work in?
3.
Works in 3. Will it work in 4?
I would think so.
Yeah, how about 100?
Sure.
It works in any amount of dimensions. That's what's so beautiful about this. Okay. So however many dimensions, this equation is a line. This is the equation of a line. Okay. Any questions on that idea first? Okay. There's only one line basically in R2, and then R3, there's a set of lines where this doesn't work for. What is that? Well, sorry, in R2, the y equals mx plus b, where does that not work? What line does that not work for? Y equals mx plus b.
A curve?
Curve's not a line. There we go. We're going to see a vertical line. But the good news is y bar or y vector equals m vector t plus b vector even works for vertical lines. There's nothing different about vertical or horizontal lines. Okay, this works for all lines, whether they're vertical or horizontal or weird looking, but any line. So this is always going to work, and it's useful. It's used in a lot of different places. So let me do an example. An example, I think you'll agree, is not hard. And that is find the equation of the line through the points 2, 4, -1, and 1, 2, 3. Any questions on the question? All right, so what we need to do is we need to find our m and our b, basically. How do you find your m when you're given 2 points? It's very easy. We've done this before in 2 dimensions. Now it's time for 3 dimensions. Do y'all remember? Okay, first minus the second, you got it backwards, actually. We typically do second minus first. So what we're going to do is we're going to do the second, and we're not going to write it as a point, we're going to write it as a vector. 1, 2, 3, minus, and then we're going to do 2, 4, -1. Nothing too fancy. I hope you can all do that in your head. What's 1 minus 2?
-1.
And 4 minus 2? Sorry, not 1 minus. 1 minus 2 is -1. And 2 minus 4?
-2.
-2. And 3 minus -1?
4.
Okay, and there's our m. Okay, whether you want to call it slope or whether you want to call it your displacement vector, it doesn't matter what you call it as long as you understand it. Okay, now let's do our b. That's easier. Who remembers how to do b in 2 dimensions and it's no different in 3 dimensions?
The y-intercept.
Yeah, but that you're thinking in kind of non-vector way. It's much easier than that. It's much easier. Not the second point. Good guess. It's the other one. It's the first point. Because we want to start at the first point and end at the second point. So it's just the first point, 2, 4, -1. Any questions on that? Okay. I know it's been a whole week already, but we did this a week ago or a week and a half ago. But we did it in 2 dimensions instead of 3, but nothing's different. It's exactly the same, except you have an extra thing after, an extra comma with an extra number. So then our equation, let's write it in vector form first, is x comma y comma z. Okay, so that's what our like y bar is. It's the vector equals m, which is -1, comma -2, comma 4 times t plus b, which is 2 comma 4 comma negative, whoops. There we go. 2 comma 4 comma -1. Any questions on that so far? Okay, so that's what's called the vector form of the equation. Okay. Sometimes we call this a vector valued function. You get that next quarter, by the way. So what we want now is let's get parametric equations. And that's just kind of putting it together. So what's the parametric equations? We have x of t is equal to what? So what's x of t here? I don't see y'all jumping in. It's pretty easy. Yeah, it's negative t plus 2. I see. There's someone who just put it in. I missed it. Okay, negative t plus 2. Then we have y of t is equal to negative 2t plus 4. And then we have z of t is equal to (4t minus 1). Any questions on the second way of writing down the equation? So the first way is by using a vector valued function to show the line. The second way is parametric equations. There's a third way. Okay, so here's what I want to do. I want to get rid of t. Because when you think about this line, there is no t in the xyz space. It's just x, y, and z, isn't it? So if we want to not have a t, how do I get rid of t? Any thoughts? Yeah, we solve for t in all three of them. So in particular, so let me write down, I haven't written this. So this is the vector valued function. The second one was parametric equations. And then the third one, we got some work to do. So we're gonna solve for t. So if I solve for t in this first equation, I get t is equal to, oops, and you get negative x plus 2. Any questions on that, on how I got that? You traditionally don't write the of t because the whole point is we're trying to get rid of t. So t is negative x plus 2. How about in the second one? What can we say t is?
Negative 2x plus 4.
Okay, in the second, first there's no x in the second one. So what does the second equation give you for t? Not just 2. It's messier. Okay, well, the idea is you have to subtract 4 and divide by 2. So we get y minus 4 over -2, divide by -2. Okay, very basic algebra. The key is do the basic algebra. How about the third one? What do you get t to be? Yeah, I get z plus 1 over 4. And just to make the first one look a little better, I can say that now t is negative x plus 2. I forgot to put the over -1 anyway. So it's, oh, let's write this. So you bring the t over, you bring the x over, and then I'm going to put over 1. There's a reason I'm going to do it. You're always allowed to do that. Hopefully you know that. You can always put over 1. But that way they all look similar. Any questions on that? All right. Well, if I have t equals negative x plus 2 over 1, t equals y minus 4 over -2, and t equals z plus 1 over 4, and I don't want to have any t's, what can I do? Yeah, I can set all the equations equal to each other, and you get a triple equality. So I'm going to write this in equation form because that's more standard. So we're going to have negative x plus 2 over 1. And I'll make it bigger in a minute, is equal to y minus 4 over -2. And that's equal to z plus 1 over 4. And we want this to be much bigger. Okay, so this is the part, this should be new, probably new to everyone. So this has a name also, just like we had parametric equations as new because we're in xyz, but it's the same as xy. But this one's completely new. You probably haven't seen anything like it before. Maybe you have, but I don't know. And this one is called the symmetric equations. So let's put these 3 in red because they're important. But it's way too big. So any questions on finding the equation of a line through 2 points? Okay, so now that we know how to do with lines, we're going to be using this all over the place. Let's do some more stuff. And that is the following. It's a theorem. So let's say L is a line passing through a point P, and V is a vector in the direction of the line. Let M be a point. Then the distance from M to L is defined by distance is equal to the magnitude of the vector PM cross V over the magnitude of V. Okay, so that may not be obvious until you kind of look at this for a little while and see that it's got to be true. Okay, I want to mention, by the way, the book does not use dist like I do, but I refuse to do what the book does, which is use D. You know why I don't want to use D? Lowercase d. Yeah, D stands for derivative. I stay away from that at all costs, or just about all costs, even though we're not doing the derivatives today. So I recommend writing more letters than just D, and then you won't get confused later on when you're doing derivatives. Okay, so this is a picture I copied out of the book, but it basically the proof comes right from it. So we're looking at, we want to find out the distance from M to L. Okay, so here's our line. And we want to find out how far is it from M to the line. Now the line is going to be a right angle, okay, across there. To find the distance, what you do is you draw the perpendicular distance, and that'll be the distance. So if you don't draw that, but if you drew M to P, you get a parallelogram. Do you remember what the cross product does in terms of geometry? If you take a vector across another vector, geometrically, what do you get? And you take the magnitude. What do you get? Yeah, you get the area of the parallelogram. So we know that the area of the parallelogram that we've gotten, which is this vector V and the vector PM, that area is the cross product. Any questions on that? All right, now you also, from way back when, not even pre-calc, pre-calc, is you one time learned that if you want to find the area of a parallelogram, you could do base times height. Do you remember that? So it happened, I promise, if you don't remember it. And the base of the parallelogram is V, and the height is the distance from the point to the line. So that tells us that the distance from the point to the line times the magnitude of V is the cross product. It's magnitude. So divide by B, and that's your distance. That's the whole proof right there. There's not much to it other than looking at the geometrical picture. Any questions on that? Okay, it's pretty easy to do, and cross products are a bit of a pain, but it's just, following the rules. So let's do an example. Let's see if you can do it. Find the distance from the point 2, -1, 5 to the line written parametrically as x of t equals 3t minus 1, y of t is 4t, z of t is 2t plus 5. So you want to find that distance. I'm going to give you a minute or two. Let's see, we got time. Yeah, I think we can do it. Let's see if you can do that. Again, I recommend all of you, don't wait for me to do it. Try to do it by yourselves, and then we'll look at it. So I'll give you a minute or two. It shouldn't take too long. And go find the distance from the point, 2, -1, 5, to the line, this guy. I'll give you a minute or so. And when you've got it, put it in the chat box and see if we're right. And if you need any help or a hint, you can ask. You put that in the chat box too. Again, if you have questions, let me know. But I think it's always good to try it also. Okay, I think I'm going to work this out because I don't want to take too long because we need to get to other stuff. And hopefully you've made a lot of progress. So the first thing is, what's the easiest point on this line? What's the easiest point on the line? Yeah, -1, 0, 5. That's just when t equals 0. I was hoping everyone would have the same thing. We have m, by the way, is 2, -1, 5. That's given. What's v? What's a vector parallel to the line? That's also really easy if you understand it. Yeah, 3, 4, 2. Okay, what's PM? That's the displacement vector from P to M. So you take 2 minus -1, which is 3. You take -1 minus 0, which is -1. And you take 5 minus 5, and you get 0. Any questions on that? Okay, you did it backwards. It turns out that if you did MP instead of PM, you actually get the same answer. And in fact, I'm not, yeah, because the magnitudes are always positive. That's the idea. So that always kills the negative sign. So if you did it backwards, you'll still be okay. That's the good news. The bad news is you did it backwards. So it's important to understand it. Okay.
I'm curious about how I can see that the slope is the same, but how did Rigney find V?
V?
Yeah.
Oh, because V is a vector from P to another point, right? Right? Does that make sense?
Yeah.
So P is a direction vector. Any questions on that? When T is, does that make sense?
Yeah, that makes sense. I'm just curious. Like, I feel like I said, I see that it's the same slope, but I feel like he picked a specific point and kept with it, and that's where.
Right. Now you could sit there and do it and let T be 1 as your second point, and then do the P. You could go from P to that second point where T is 1, and if T is 1, you get 2, 4, 7, and then you'll end up with 3, -1, 0.
Oh, got it now.
Okay. But you didn't have to do all that because those coefficients always give you the displacement, because that's how those came from. They came from the displacement. Do you remember that? You found those coefficients by subtracting the 2 points.
Yep, I got
And
it.
that's
now.
how you find V.
Thank you.
Okay, so it turns out it's just easy. Okay, so next we need to find again PM cross V. And that again is I J K, and then PM is 3, -1, 0. And V was 3, 4, 2. So now let's take that cross product. So the I component, we're going to have -2 minus 0. So that's just -2, comma, the J component, kill that and that, and you get 6 minus 0, and it's negative that, so -6. And the K component, you get 12 minus -3 is 15. And now I want the magnitude, so I'll just do this all together. And that's the square root of 2 squared is 4, plus 6 squared is, or -6, -2 squared is 4, -6 squared is 36, plus 15 squared is 225, or the square root of that is 2, so 36, 4 and 36 is 40, so 265. Okay, and then finally, V, want the magnitude of V. That is equal to the square root of 3 squared plus 4 squared plus 2 squared, or 9 plus 16 plus 4, which is equal to the square root of 29. So the distance is just going to be the square root of 265 over 29. Any questions on using the distance formula? Okay, so let's continue on. Again, today's big geometry day. So here's a question. If you have 2 lines in a plane, okay, if there's 2 lines in a plane, and I tell you they're not parallel, do they intersect? If I have two lines in the XY plane, you know,
Possibly.
and they're not parallel, do they intersect? The answer is absolutely, not possibly. Absolutely, they intersect. What if I say we have 2 lines in space now, in 3 dimensions, and they're not parallel? Do they intersect?
Not always.
Yeah, definitely not necessarily. So for example, if you're indoors, you could do what I'm doing and look at where your ceiling connects the wall, and you'll see a line, right? Okay, but then you can look, so that if you look to the right and you see your ceiling connecting the wall, you'll see a line. And then look ahead, you'll see where your wall connects the floor that is not on the same wall. So do a perpendicular wall where it connects the floor, and that's a line also, and those lines do not intersect and they're not parallel. So you have to be real careful about using what you know about 2 dimensions, saying, it must work in 3, because it's not true. So we can actually have 3 different types. Lines can intersect, they can be parallel, or if they're neither, we call them skew. That would be like this. Let's see if I can put it in the window there. That'd be like my 2 fingers. So my fingers are not connecting. They don't intersect. They're not parallel to each other, but they're what's called skew. Any questions about skew lines? Okay, and they could be any of them, any of the above. All right, so here's an example. So let's suppose we have these symmetric equations, 2 different lines. Are they parallel, skew, or do they intersect? Are they parallel first? How can you look at it and know immediately yes or no?
The coordinates.
Okay, if they're parallel, then these denominators would have to be the same. Okay, they don't have to be, if they're exactly the same lines, then they're not parallel, they're just the same line. That's not 2 lines, that's 1 line. But they're definitely not exactly the same line, but they're not parallel, because this x minus 2 over 3, the over 3, does not match the over 2. Do you see how that works? So if it did, then if all of those match, they're parallel, because that's kind of the slopes. And if all the slopes are the same, you get parallel lines. Any questions on that? So they're not parallel. How do we tell if they intersect? How do you tell if they intersect or not? Yeah, kind of set them equal. So that means that there's going to be a point xyz at which all 6 of these are equal. Any questions on that? Is that clear? So there's going to be a value x, y, and z where you get equality. Okay, so in other words, there's a value x, y, z on the first line, and there's a value x, y, z on the second line. That does not necessarily mean x minus 2 over 3 equals x minus 1 over 2. What we've got is 6 equations and 3 unknowns. Or sorry, 4 equations and 3 unknowns. Okay, I think the easiest way of doing it is actually thinking of it parametrically. And we know that for the first one, x is equal to 3t minus 2. Okay, because we set them all equal to t, 3t minus 2. And for the second one, y is equal to 2t plus 1. And for the third one, z is equal to 4t plus minus 1. Any questions so far? Okay, so we know that's true. And for the second equation, we can say x equals 2t plus 1. Y equals t plus 3, t minus 3. And z is equal to 3t plus 1. Any questions on that so far? All right, well, now what I can do is I'm going to use the easiest of these, which is the y's, because y just has a t minus 3. So the question is, do they intersect? So if they intersect, that would mean that there is a t for the first one and a t for the second one, a different t, where you get the same y and the same z and the same x. So in particular, instead of calling it t, let's call it a and b, because there's going to be time a for the first line, time b for the second line, at which these equations are satisfied. Any questions so far? Okay, so now if y equals 2a plus 1 and y equals b minus 3, then b minus 3 is equal to 2a plus 1. Or b is equal to 2a plus 4. Any questions on that? All right, so if b is 2a plus 4, I can pop that into the x equation. And we know that 3a minus 2 is equal to, well, this x and this x has to be the same. And we have 2 times b, which is 2a plus 4. Plus 1. Okay, any questions on that? All right, well, that gives us that if you work this out, we get 4a plus 8. Let's write it this way. Plus 8 plus 1, which is plus 9. Any questions so far? Subtract the 3a, subtract the 9, and you get a equals negative 11. Okay, just basic algebra. Well, if a is negative 11, let's put it into the z formula. Then that means that z is equal to negative 45. And similarly, if a is a negative 11, then z is going to be 3 times b. Well, if a is negative 11, then b is negative 22 plus 4, which is negative 18. And then plus 4. Well, 3 times negative 18 is negative 57, plus 4 is negative 53. Well, now I got a problem because the z's have to be the same. 54, sorry. You're right, 54 not. So 54 plus 4 is negative 50. Try and do this too quickly. And negative 50 and negative 45 are not the same, so that means they don't intersect. So therefore, the lines are skew. So a lot of basic algebra. I'm going to move on because I don't want to focus on real basic, solving equations. That's not really, hard calculus. It's just messy. Okay, so now comes a few things, and this is really important. You know that the cross product of two vectors are orthogonal to each of the two vectors. Hopefully you remember that. That's really important with cross products. Okay, if you know that a vector is orthogonal to a non-parallel vectors on a plane, it's orthogonal to every vector on the plane. Does that make sense? So here are the steps to find the equation of a plane. Step 1, find two vectors on the plane, v and w. Often you find the two vectors. If you're given 3 points, they could be the displacement vectors. Okay, that's your typical way of doing it. Step 2 is take the cross product, and that'll give you a normal vector, or a vector that is orthogonal to both v and w, which means orthogonal to the entire plane. Construct a general vector on the plane, this is step 3, using the displacement vector formed from a known point, ABC, on the plane, and a general point, xyz, on the plane. So if you take the displacement vector between ABC and xyz, it's x minus a, comma y minus b, comma z minus c. That's how you do displacement vectors, as you subtract. So that gives you a point on the plane. So if you have a point on the plane, and you have a vector that's orthogonal, it gives you a vector on the plane. If you have a vector on the plane and you have a vector that's orthogonal to the plane, and you dot them, you get 0. So that means n dotted with x minus a, y minus b, z minus c is equal to 0. And that gives you the equation of the plane. Okay, so again, it's a lot of instructions. Let's do it by example. It's a lot easier to understand. And this comes up in a big way. So it says, find the equation of the plane that contains the points 1, negative 1, 0, 2, 1, 1, and 0, 2, negative 1. So let's go through the steps. How do I find two vectors on the plane? How do I find a vector on this plane if I have 3 points? Hint is it's easy. So how do I find a
It'd be
vector?
1 times 1.2 plus negative 1.1.
Okay, you're making it way too hard, way too hard. Much easier. How do you find a vector? If I have 3 points on a plane, how do I find a vector on the plane? Really easy.
Could you just subtract one from the other?
Yeah, just subtract. Isn't that easier? Again, your way might have been right when you gave me that other with dot products and stuff, but no, just subtract. So 2 minus 1 is 1, comma. 1 minus negative 1 is 2, comma. 1 minus 0 is 1. And then I need to find another one. So instead of taking the first 2 points, how about the first and the third point? Let's call that W. And that gives me 0 minus 1 is negative 1, comma. 2 minus negative 1 is 3, comma. Negative 1 minus 0 is negative 1. Any questions on finding 2 vectors that are on the plane? Okay, so that was part 1. Part 2 is take the cross product. So I need n equals v cross w. So let's do that. So we have ijk. And then we have 1, 2, 1. And negative 1, 3, negative 1. Okay. And now I take the cross product. So the I component, we're going to have negative 2 minus 3, which is negative 5. So I'm going to write n equals negative 5, comma. The j component is going to be negative, and then it'll be negative 1 minus negative 1, and that's 0. And the k component will be 3 minus a negative 2, which is 5. Any questions so far? Okay. So now let's look at the next step. We just found the cross product. Now we're going to take x minus a, y minus b, z minus c. So we're going to look at a vector. And that's going to be on the plane. And that's going to be, so on the plane will be x minus, pick any point. Let's just pick the first point. It really doesn't make any difference. X minus 1, comma, y minus negative 1 or y plus 1, comma, z minus 0 or z. And then the next step is I take n dot that vector, set it equal to 0, and then simplify and I'm done. So I'm going to take negative 5, comma 0, comma 5, dotted with x minus 1, comma y plus 1, comma z, and that's equals 0. And now let's do the dot product. So that gives you negative 5 times x minus 1 plus 0. I'm going to write the plus 0 even though you don't have to. Plus 5 times z equals 0. And now I simplify, I'm going to solve for z. And I get z is equal to, I can add that up, divide by 5, and you get x plus 1. And that's going to be a plane. Any questions? Any questions on this process? Okay, it's a step-by-step process, but it's really important. Okay. I think I'm gonna not do the next example because we don't have much time left. I think I have a little more to do. So let's take a look at a point, and we want to find out how far a point is to a plane. And by definition, the distance from a point to a plane is that perpendicular distance. So we want to find out that distance right here. Okay, and the way you do that is we know how to find the normal vector to a plane. So what we want to, so here's our normal vector. Take a point in the plane, and we can take that vector from that point Q in the plane to P. And this vector here is going to be the projection of this vector QP onto N. And the distance will be the magnitude of that projection. So in particular, the distance from a point to a plane is a projection onto N of QP, which, if you remember, was the absolute value of N dot QP divided by N. Any questions on that formula? All right, so here's an example.
Larry, don't you have to then multiply it by the vector of n? If I remember correctly, or is that?
When you say multiply by the vector n.
Oh no, actually, never mind. I'm confused. I had it as, isn't it the? No, never mind. I have something written down for projection from last class.
Yeah, this is the this
different.
is the length of the projection.
Oh, I see now. Yep, my bad.
Which is different than the projection. So the projection is a vector, but we want the distance, which is a number instead of a vector. So that's why these absolute values and the magnitudes. Okay. So if you want the vector, then you got to multiply by n, but we don't want the vector, we want the length of the vector. Okay. So that, I think that might be where you're confused as you're thinking about the vector instead of the magnitude. Okay, so find the distance from the point 4, negative 1, 3 to the plane 2, x plus y minus 3z equals 6. All right, so the first thing is, what is n? The hint is it's very easy. What is the normal vector to this plane?
Would it be 2, 1, negative 3?
Exactly. It's 2, 1, negative 3. So let me remind you why. Remember that we know that n dotted with x minus x naught, comma y minus y naught, comma z minus z naught is equal to 0. That's how we got the equation of the plane. Well, when you dot these, n is going to be the 3 numbers. And when you multiply those 3 numbers into each of these, then you'll notice the first number from n will be the coefficient of x. The second number of n will be the coefficient of y. And the third number for n will be the coefficient of z. So we know that the normal vector, once you're given an equation of a plane like this, is just the coefficients of x, y, and z. So it's really easy. Easy is good, isn't it? So we know that's n. So now what is n dotted with PQ? So we need a PQ. So we need a point on the plane. So let's do that. So we need to get a point on the plane, and from the picture, notice that was Q was a point on the plane. So Q is equal to, how do I get a point on the plane? That's an easy way. Here's our equation of the plane. That's a hint. And one easy point.
Make something 0.
Yeah, how about not something, some things, X and Y.
Okay, make all of the coordinates 0.
No, you can't make all of them 0 because then you get 0.
Oh wait, yeah,
How about X and Y?
yeah.
So if X is 0
Then z equals 2.
and Y is 0, then Z is equal to -2, right?
Yeah, sorry.
Okay, so Z equals -2. So we can let Q be 0, 0, -2. Again, if we let Y and Z be 0 and you got 3, 0, 0, that's fine too. You get the same answer when you're done. Okay, so in particular, we're going to take N. Actually, let's write N. 2, 1, -3. And then we're going to dot it with the displacement vector, QP. So it's going to be 4 minus 0 is 4, comma, -1 minus 0 is -1, comma, 3 minus -2 is 5. And what do you get?
Two.
Okay, so you get 2 times 4 is 8. 8 minus 1 is 7. And 7 minus 5 is 2. And I want to note, even though in this example it doesn't matter, but some others it might, we want the absolute value of it. And the absolute value of 2 is also 2.
Can you explain how you got that again? The 4, -1, 5.
How I got 4, -1, 5? Oh,
Yep.
that was just, so that's, again, we're looking at this QP thing. And QP is, here's Q. Here's P. So we're going to take 4 minus 0 is 4. And then -1 minus 0 is -1. Wait, 4. Yeah, -1. And then 3 minus -2 is 5. Does that make sense?
Yeah, thank you.
Yeah, so it's a displacement vector. Okay, the magnitude of N is equal to, and running out of time, so let me just do it in my head. 2 squared plus 1 squared plus 3 squared, that's 4 plus 1 is 5, plus 9 is 14. So it's the square root of 14. So that means our distance is equal to 2 divided by the square root of 14. And that's the distance from the point to the plane. And the nice thing is that wasn't that hard, was it? I mean, it's steps, but not that bad. Okay, I don't have time, but this is also a distance formula. This really is the same thing, and it can be proven pretty easily. Is that ax naught plus by naught plus cz naught plus k divided by the square root of a squared plus b squared plus z squared. That's kind of doing it all at once. But I kind of like the geometry way of looking at it. Okay. So consider the planes x minus y plus 2z equals 4, 2x plus y minus 3z minus z equals 3. Do these planes, it shouldn't be lines, planes, intersect or are they parallel? If they intersect, find parametric equations for the line and the angle. So how do you tell if they intersect or if they're parallel? Or let me just put it this way. How do I know they're not parallel? Just by looking at it quickly. I see a question, 2, 1, -1. Oh, that should be -3, shouldn't it? Let's double check. Yep, that should be -3, not -1. That changes a few things. -15, -16 minus 8 plus 8 is -8. And that should be an 8. And the 2 should be an 8. Thanks. How do I look at these and know they're not parallel? How do I look at these two planes? Immediately? How do I know they're not parallel? Any thoughts? Yeah, the different coefficients of normal vectors are not constant multiples of each other. Because if they're parallel, the normal vectors should be parallel. And the first normal vector, let's go n1, is equal to 1 comma -1 comma 2. And n2 is equal to 3, 1, -1. And those are clearly not multiples of each other. They're not in the same direction. So the planes intersect. Okay, how do we find the angle between the two planes? Any thoughts? Hint, n1 is this vector, n2 is that vector. So how do we find the angle between the two planes?
You take the arc cosine of the dot product over the magnitude.
Exactly. So theta is equal to the arc cosine of the dot product of n1 and n2 and then we divide by the magnitude of m1 times n2. Okay, I'm out of time, but that's just busy work. Hopefully you know how to find dot products, you know how to find magnitudes, and you just plug in. Any questions on that idea? How do you find parametric equations of the intersection? Any thoughts? So the idea is if you have these two equations, you can solve one for z, and then you can let z equal 3x plus y minus 3. Plug that in for z. And that will give you x in terms of y. You can always call it xt, and then you'll get y as t, and then you can get z as t. Can I just see the last problem for a picture? Sure. You mean the previous problem, not the last problem, the second to last problem. But we're out of time. So I'm going to stop the recording so you can take a picture of this, and then I'll unshare.